Welcome to 9 Maths Simultaneous Equations. In this lesson, we're going to use efficient methods to solve simultaneous equations in two variables. Introduction. Below are three set of examples of simultaneous equations. They are basically equations that have solutions that satisfy both equations. For example, whatever number we give for x and y here to add to 7, those same numbers should be used here to give us answer 1. Let's start with an example. The most basic method is to use a trial improvement method. So let's say to have x add y, we can consider 6 add 1 to give us 7, which is true. Then we try the 6 and 1 again. 6 minus 1, we expect to get 1, but this is giving us 5, therefore that is not suitable. We then try 3 add 4, that will give us 7, but then 3 minus 4, that will give us minus 1, which again is not suitable. We're looking for that. We try another one. 4 add 3 equals 7, and 4 minus 3 will give us 1, which is correct for both equations. Hence we say our x is 4 and y is 3. We could also use a graphical method to solve the same equation. So the next thing we're going to look at is the graphical method. So with this method, we need to draw graphs of both equations on the same grid. So let's start with x at y equals 7. I'm going to use the intercepts method to draw those graphs. So I'll start with if x is 0, then y will have to be 7. So we have 0, 7. And if y is 0, then if y is 0 here, x will have to be 7. Hence we have the point 7, 0. So those are the points that will give us the line x plus y equals 7. Now let's do that of x minus y equals 1. If x is 0, then y has to be minus 1 to give us the answer 1. So our point will be 0 minus 1. And if y is 0, then x will have to be 1 to give us the answer 1. So our point will be x. The pair of the point will be 1, 0. So what we are going to then do is to plot this on our graph. But to do that, we need to think of how our graph will look like. So the best thing to do is to just do a quick sketch. Look for the x interval. So we have 0, 7, 0, 1. So the highest is 7. So for x, we're going to get to 7 from 0. And then for y, we have 7, 0, minus 1. So it means we're going to have minus 1 all through to 7 for our y. So if we consider a point here, that will do. Let's take somewhere 1, 2, 3, 4, 5, 6, 7. So that's okay. Let's take here 1, 2, 3, 4, 5, 6, 7 as well. So if we take here, we can have our minus 1 here all through to this. So I'm going to use this. That's my x, and that is my y. I've got x and y. Got our 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Then 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, and 7. That means our minus 1 is down here. That will be minus 1. So we're now going to plot the points 0, 7, 0, 7 for that one, and then 7, 0 for this. So join this point to that point and extend it as long as we want, and that will be the line x at y equals 7. Then for x minus y equals 1, we have 0 minus 1, so 0 minus 0 minus 1 is here, and then 1, 0, 1, 0 is here. We join these ones as well this time. Go through that. So again, this will now be, these are x minus y equals 1. The point of intersection is our answer. So we'll read that point here, x equals 4, and you read this there, you have y equals 3. That's our answers. Let's try another question using the graphical method. So we're going to start with x at 2, y equals 4. So we say that if x is 0, then that will be 0, 2y will be 4, therefore y will have to be 2. We have 0, 2. And if y is 0, then that will be 0. This implies x has to be 4. So we have 4, 0. For line 3x add y equals 9, we say that if x is 0, that will be 0, therefore y will be equal to 9. And if, so we have 0, 9. And if y is 0, that will be 0, therefore 3x equals to y, meaning x will have to be 3. We have 3, 0. Again, we have our quick sketch to see how it's going to look like. So just a sketch. So the x's are 0, 4, 0, 3. So that means it's going to be from 0, 0 through to about 4. And for the y's of 2, 0, 9, 0. That means from 0 all through to 9. So if we look at that, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere here will be good. Or let's just do it here. So we have our x axis needing 0 to 4. So anything covering 0 to 4 will be great for our x. And for our y is 0 all through to 9. 0. So that is our y-axis. So we have 0, 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we then plot the point 0, 2, 0, 2 will be there, and 4, 0, 4, 0 is here. We join this up. This point, that point, we could extend as long as we want to give us the line for x add 2y equals 4. Then for 3x add y equals 9, we have 0, 9, 0, 9, and 3, 0. Join this up. 3, 0, and 0, 9. once again we get our line. This is the line 3x at y equals 9. The point of intersection is here, so we'll read the values for that to give it our solution. So that bit is about 2.8. So we say that from here, you see we're going to get 2.8, and that bit is about 0.2, 0.4, 0.6, about 0.6. Now these are just rough estimates. So we say that our x is about 2.8 and our y is about 0.6. So these are rough estimates. We can check to see that it will be close to 4, but not exactly that. So we have 2.8 add 2 times 0.6. We get this, give us 4 exactly, which is great. Then we'll try that here. 3 times 2.8 add 0.6 give us 9. Oh, so our approximations were bang on right. Now the problem with this graphical approach is that sometimes if we don't get whole number answers, our approximations will not be exact, but it's okay. Now stop the video and try some exercises on using graph to solve simultaneous equations.